Hey everyone, welcome back. So this quick video is for those of you who would like to see where the work energy theorem actually comes from. So this is just a quick derivation. And sometimes I talk about an equation in my class called the forgotten equation. And if you remember, the forgotten equation was something like this. V final squared equals V initial squared plus 2 times acceleration times change in distance. Okay, so the first thing that we're going to do to this equation is we're going to make it mad. We're going to multiply everything in the equation by m. And we don't need to worry about the change in sign, so we can just take that guy out. So what this does is, that's why I said it makes us mad. We have mass times acceleration times distance. Next thing we're going to do is we're going to divide everything by 2. So we're going to get 1/2 m v final squared and 1/2 m v initial squared. And then we're just going to be left with m, a, and d. Okay. So you might remember from way back when that if you take mass and multiply by acceleration, you get Newton's second law, or the net force. So that means that we can replace ma with F for force. And so that turns our equation into something that looks kind of like this. I'm also going to take the 1/2 mv initial squared and subtract it so it's on the other side. Okay, so now I have an equation where on one side it looks like I've got masses and velocity squared, and on the other side I have force times distance. Now this is not just any force, this is the net force. And when we take the net force and multiply it by distance, that is the net amount of work that's done to an object. So on the left side, 1/2 m v final squared is probably something you recognize. That's actually the final kinetic energy. Likewise, 1/2 m v initial squared is the initial kinetic energy. And so if I flip the sides of this, on one side I have the net work, and on the other side I have Ke final minus Ke initial, which, if you remember, anytime you have final minus initial, that's a change. So that's a change in kinetic energy, and there's the work energy theorem. It comes from the forgotten equation and kind of switching things around. So there you have it.